All right, so y'all go ahead and do the factoring and math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x minus 1 times x minus 5. For the math knowledge question, it says we have a quadratic function. What could be the coordinates of P? So P is right here, and it is a quadratic. So this is a parabola. So this point right here is going to be halfway in between 1, 0 and 4, 0. So somewhere halfway between. What is halfway in between 1 and 4? Hopefully you said 2.5. So this point right here is going to be 2.50. And then P is going to be 2.5 and then up something. But if you look over here, there's only one where the x value is 2.5. So that's going to be your answer for P. So we're looking at lesson 6 in calculus today. We're going to look at functions, functional notation, and domain and range. Hopefully you'll understand equations and graphs of functions. You'll remember functional notation either from pre-calculus or algebra 2, and you'll hopefully have a little bit of a memory of domain and range. Maybe even from biology you might have dealt with a little bit of domain and range, but you should have a vague understanding of at least some of this stuff. So a function is the process where you produce exactly one answer for each value that you choose for your input. So if you put something into your function, you're only going to get one answer spit out from your function. Your domain, those are your x values, your input values. Whatever you're putting in, that is your domain. Your output are your y values. Those are your range values. So your domain is related to the x. Your range is usually going to be related to the y values. Function cannot repeat the input values, your x values. Your domain cannot be repeated if it's going to be a function. So function domain doesn't get repeated. Your x values are not repeated. So looking here, we want to find f of negative 2, f of x plus 2, and f of x plus, this is delta x. You may be familiar with delta. It's just a Greek letter if you're not familiar with it. All right, so our function is f of x equals x squared plus 5. So for part A, the first one, we're looking at f of negative 2. Everywhere you have an x, you're going to replace it with a negative 2. So negative 2 squared is going to become 4. And then plus 5, that gives you 9. Don't try and solve for f. That's a rookie mistake on these. You're just looking for f of negative 2. F of negative 2 equals 9. You got your answer. Now you move on. For part B, f of x plus 2. So again, everywhere you have an x, you replace it with x plus 2. So instead of x squared, we're going to do x plus 2 squared. And then plus 5. So if you distribute, you have x squared plus 4x plus 4 plus 5. And then you're going to do x squared plus 4x plus 9 to combine your like terms, and that's as far as you can take it. So there's your answer right there. For part C, again, everywhere you have an x, we're now going to replace it with x plus delta x. So instead of it being x squared, it's going to be x plus delta x squared, and then plus 5. So you distribute, just like on the last one, you get x squared plus 2x, and then delta x is a separate variable from x. So don't try and make that delta x squared or anything. Keep them separate. And the best way to do that is just to keep delta x in parentheses separated from the x. So 2x delta x. And then plus delta x squared. And so that distributes everything. And then we have the plus 5. None of these terms are like, so we can't combine it any further than leaving it right there. So that's your answer for part C. So that's just using your notation for functions. For this one, it says to use a graphing calculator to estimate the value of these three, where f of x is 1 over the square root of 1 plus x squared. So go to your graphing calculator. So we need to go to y equals. And if you have anything in there, you need to hit clear and then enter, and then clear and enter. And I'm going to go back up to y1, and I'm going to plug in my function, 1 divided by, and I'm going to put parentheses, and then square root of 1 plus x squared, and then I'm going to close parentheses. On this particular one, those parentheses aren't exactly necessary because you only had one term in your denominator, but if you're ever not sure, go ahead and put them. And then you hit enter. Now we don't have to graph this, like we don't need to know what the graph of it looks like, but we just go ahead and graph it because that's just going to be the easiest way to get to what we're looking at. And so we have our graph. It doesn't matter what it looks like. What you're concerned with is the value at those points. And so you're going to go to calculate, you're going to hit second, trace, and you're going to go to, any guesses? Hopefully you guessed 1. And so our x value, we are looking, if you look here, it says the square root of pi. So you're going to type in the square root of pi. And then you're going to hit enter. And it's going to tell you, so this is what the square root of pi is. That was our x value. We're looking for the y value. So this is our y value, 0.4914. So you can write that for your part A. For part B, we're going to go back to calculate, and we're going to do value again, and this time we're going to do square root of 2. Oops. If you look at square root of 2, this is square root of 2. That's what we plugged into our function. It gave us our y value of 0.5774. We always round to 4 decimal places this year. So that's your A and your B. Now for this next one, do you see where it says cosine of 5 squared to 3? You need to make sure your mode is in radians. If it's not, you need to change it. So if it's in degrees, it would look like this. And so what you're going to do is go down until it's flashing on radians and hit enter. And so now it's in degrees. So now you're just going to go second, calculate, and you're going to go to value, and you're going to type in cosine of 5 square roots of 3. And then if you hit enter, you should get 0.8109. So that should be your answer for part C. So that's how you can use the graphing calculator to estimate on functions. Makes it to where I can't help you, unfortunately, if this is on a test and you just put your answers, because I won't necessarily know what you did wrong because you're not going to have any work. But it does make it pretty easy to do if you know how to use the calculator. Alright, so this one, it says use the graphing calculator to find the values of f1, f2, 3, all the way to 10. And it's the same function. So I'm going to show you what I can do on these. Instead of going over to calculate, do y'all see above graph where it says table right here? It's in blue, so we have to hit second and table, second graph. And these are our x values. And if you look, these are the y values. So f of 1 gives me this number here, which looks like it's 0.7071. F of 2 gives you 0.4472. And so you can scroll down, or you can, yours may not show all 10 of them. You may have to hit the arrow down to get to more of them. But that's how you can easily look at whole numbers for this particular one. And if you want to, you can play around with table. It says if you hit the plus sign, you can change your table. So if you're interested in doing that, you can do that on your own time. You can look it up and see exactly how to manipulate your table a little bit more. All right, so now looking at this example. Which of the following are not graphs of functions? So a function is always going to pass the vertical line test. So at any point on our graph, if it has a vertical line that can be drawn where the graph touches our vertical line more than once, then it is not going to be a function. So this first one, no matter where I draw a vertical line, it's always going to be touching it at one spot. So this one is a function, but it says which are not functions. So not A, it is a function. For B, if I draw my vertical line, I only have to draw one, and I've got two places that it crosses. So this is not a function because we have a vertical line that crosses at 2 and it touches twice on our graph. For part C, if you draw vertical lines, it doesn't have a vertical line that ever touches it more than one spot. However, so it says not function, not graphs of function, so we wouldn't take it. So we move on from it. For D, here is only touching at one spot, but if I draw a line here, or here, or here, it is touching it everywhere on these places. And so this is not a function either, because it does not pass the vertical line test at this spot, or that spot, or that spot. So B and D are the two that are not functions. All right, so now we're going to look at ordered pairs. When you're looking at ordered pairs, you are mainly concerned with the x value. Does the x value repeat? So if we look here, we have 1, 2, 3, and 4. Did any of those repeat? No? So this is a function. I'll change to black. That may be hard to see. On this one, we have 1, 2, 1, and 4. I said 1 twice. So 1, 2, and 1, 3. Those aren't the same point. If it was the exact same point, then it would be considered a function. But since they are not, our x value repeated with a different y value, so that one is not a function. Looking at the next one, we have 4, 2, 4, and 3. I said 4 twice. This is 4, 3, and 4, 3. That's the same point. That's allowed, so that is a function. Looking at the next one, I have 1, 4, -1, and 3. None of those repeated, so that is a function. All right, so now looking here, determine whether the following statement is true or false, and then justify it. So it says the mapping, taking our function in terms of x, and the equation would be x to the 4th plus x squared, is not a function because it maps both +1 and -1 to +2. So it says that the equation x, or the function x to the 4th plus x squared is not a function because when we plug in 1 and -1, we get 2. So is that true or false? Feel free to pause the video if you need to think about it for a minute longer. I'm about to tell y'all the answer. It is false. The reason, it is a function. If you plug in 1, you only get one value. You get 2. If you plug in -1, you only get one value. It is also 2, but that's okay What is not okay is plugging in a value and getting two different numbers. It's perfectly legit, perfectly okay to plug in multiple numbers and get the same answer. So a function can have two different values of x that produces the same y value. That is completely okay. So this one is a false because it is a function. Okay, looking at this one, determine whether it's true or false and explain your answer. The equation y equals 1/2 x squared plus 2 is not the equation of a function because there is a vertical line that intersects the graph of this equation at more than one point. So 1/2 x squared plus 2 is a parabola. There's a parabola. Is there ever going to be a vertical line that intersects it at more than one point? No. So this is false. Anytime you plug in an x value, you're only going to get one value here. So every vertical line is only going to hit it at one point. It does not fail the vertical line test. It actually passes the vertical line test. All right, so now looking at domain and range of the function. Domain is related to your x values, range is related to your y values. So what numbers can we plug in here? Well, we've got a radical. So inside of our radical, the x plus 5, we can't have it be negative. So x plus 5 has to be greater than or equal to 0 because we are dealing with real numbers. We can't do the square root of anything less than 0. Which if you solve this means that x has to be greater than or equal to -5. So for your domain, I just write D instead of actually writing out domain. X is an element of the reals such that x is greater than or equal to -5. And that's how you would write your domain for this function. X is an element of the reals. That is the symbol that we learned back at the first lesson. This is just, it's kind of like a C with a little line there. It's a little E, and then you draw a vertical line such that x is greater than or equal to -5. So that's your domain. For your range, those are your y values. What kind of numbers do we get out using our calculator when we plug in square root of any number? Square root of 0 would give you 0. Square root of 1 gives you 1. Square root of any positive number is going to be a positive number. We can't plug in, or we can't have negative numbers under here. We can plug in -4 because -4 plus 5 gives us a positive number. But we can't do negative square root or square root of -1. So your range on your radical, y is an element of the reals. Y is in the reals such that y has to be greater than or equal to 0. Because you're only going to be getting positive answers here. Okay, so now we're going to use the trace feature to verify the domain of f that we had in example 6.8. So I'm going to go back here and go to my calculator. When we use the trace feature, we need to go to y equals. So you need to type in the square root of x plus 5, and then hit enter and go graph it. So it should come up like that. And if you look, your x values, you hit trace and you start going to the left. It's getting close to -5 on our x values. We have -5 and we have 0. And then if I go to the left, what happened to my y? It disappeared because our y value is only going to be greater than or equal to 0, not anything less than 0. So that can help you verify if you use trace on your calculator. Okay, so now we're going to find the domain and range of this function, the square root of x over x minus 2. So first off, when we have a radical, what does that mean here? What numbers can we plug into the radical? Our x has to be greater than or equal to 0 because what's inside of the radical cannot be negative. So for our domain, X is an element of the reals, X is a subset of the reals, X is in the reals, however you want to say that, such that X is greater than or equal to 0. Now I'm not finishing it because we have something else to go right here. We also have a denominator to look at. We cannot have a denominator that equals 0 because then it doesn't work. You can't divide by 0. So x minus 2 cannot equal 0. So that means that x cannot equal 2. And so those are your two domain components. X has to be greater than 0 and it cannot equal 2. For the range, we only get positive numbers up here. So we're going to have positives. And then we have x minus 2. So if I plug in 0 here, I can plug in 0. 0, and then 0 minus 2 gives me negative 2. So 0 divided by negative 2 is 0. So I got 0 that worked. If I plug in a, let's say 1. 1 minus 2 would be negative 1. 1 over negative 1 is negative 1. So I can get a negative number. I'll plug in 10. 10 minus 2 is 8. That's a positive number, right? 10 over 8. So I got a negative number here, I got positive numbers, and I got 0. So your range on this one is just all real numbers. Because you can get negative numbers, you can get positive numbers, and you can get 0. So that's how you can find your domain and range on these. You have to think very carefully about domain and range. You got to make sure that you are thinking about every possible step. And the best way to do that is to practice on your homework. So make sure that you do 1 through 25 tonight, and then we can go over any questions you have tomorrow.